Hello students, in this video I'm going to demonstrate to you that how we are going to perform our activity number 4, which is based on the discrete probability distribution. So in this particular part, we are given, I'm going to share with you this particular questionnaire in which contains the problems based on the discrete probability distribution, like the binomial distribution, negative binomial distribution, and the geometric distribution. Okay, so I'm going to show you that how we are going to perform this activity if we are given certain information here. So let me consider one Excel sheet here. I'm considering a blank Excel sheet. So the first one is suppose I want to go from the activity related to the binomial distribution. So in case of binomial distribution, suppose that we are given the number of trials, say we are given 15, and we are given the probability of success, say let it be zero point 0.3. So in this case, if for the binomial distribution, let us suppose that x, which is the random variable representing the number of successes. So because I am considering the number of trial as a 15, so our number of successes may vary from 0 to 15 only, right? Okay, so this is the value of x, and suppose in the next column we are considering the probability distribution f of x, and in the next column we are considering the cumulative probability distribution function, the capital F of x. So now I'm going to demonstrate you so that what kind of command we need to use so that we can get the probability distribution as well as the cumulative distribution function for the binomial distribution only. So firstly, I'm going to use the function of binomial distribution. So for that, I'm going to use the command bin. So we need to select this particular option, binomial distribution. So when I click on that, so it requires this information. Firstly, number. Number means number of success we require. So suppose that I'm selecting this particular box, which gives us the number of success required is 0. And then the next information I need the trials. So here I'm assuming that 15 is the number of trial and the probability of success. Like in case of binomial distribution, we have a two parameter number of trial and the probability of success, which remain constant throughout the experiment. I'm simply writing its value as 0.3. I'm going to fix its value. Now, if I want to calculate the probability mass function, then I need to use the command of false, and it will use us the probability mass function, right? So here I will use the command of probability mass function. For that, we need to type false, right? And if I need to calculate the cumulative distribution function, then I'm going to use the same command of binomial distribution. So binomial distribution, when I select this, firstly, the number of successes, that is 0 only. Number of trials, the trials is 15. Probability of success is 0.3. And now I'm going to calculate cumulative distribution function. So for that, we are going to use the command of true. We need to type true here for cumulative probability distribution function, right? So for 0 successes, it will remain same. So if we want to calculate its value for the different values of x, I simply like you can see here, for this particular one, we are using H7. H7 is corresponding to this particular box, means corresponding to 1 success, corresponding to 2 success, 3 success, and similarly here, we are given the cumulative distribution function for 1 success, for 2 success, because Cumulative distribution function is that probability x is less than or equal to x, right? This is the formula for the cumulative distribution function. Okay, so this is how we can calculate the, we can perform the activity based on the binomial distribution. After this, if I need to perform, if I need to plot the graph of the cumulative distribution function, probability distribution function for this value of x, so what I need to do, I need to select this data, go on the option of insert. So here I need to consider the option of a 2D column, but instead of this, I'm going to use the more column chart. So when I click on that, so we have option here. So you can see here we are having two options. The first one is blue line, and here we have a blue with orange line. If we click select this one and click OK, so we can get the graphical demonstration of this particular problem of binomial distribution. Okay, so what we have considered here in the problem of binomial distribution, we are given the number of trials, we are given the probability of success. So with the help of this information, we firstly calculate the probability mass function and the cumulative distribution function using the command of binomial distribution. And then we can plot the graph with the help of this command, right? Okay. So now the next one is, so how can we perform the, how can we solve the problem based on the negative binomial distribution and the geometric distribution? So in case of, say, again, I'm saying that we have repeated the experiment, say 15 number of times, the probability of success is given as 0.3. But in case of negative binomial distribution, we required two more information. First one is the number of success, which we are used denoted with the letter R. R here represent the number of success. Number of success. Okay, so we denoted with the letter symbol R. And say in this case, for example, I need say 5 successes are required. Then for the command of negative binomial distribution, we need one more information, that is number of failure. For example, if we say that we have repeated the experiment 15 number of times and 5 is the number of success. So what does it mean? It means that in case of negative binomial distribution, our random variable x represent. So basically, this is not n, this is x. X represent the number of trials required to get rth success. So if I say that in 15 trials, we get fifth success, it means that the remaining 10 are the failures only. So how many failures we have? That is x minus r. These are the number of failures. So this is equal to 10. Okay. So if I want to calculate the probability distribution function for 5 number of successes, so how we are going to calculate this? So say fx, I want to calculate it. This can be calculated with the command negative binomial distribution. We need to type negb. So it will give you this option. So when I select this, so for this particular part, what kind of information is required? The first one is number of failure. Number of failure, like I told you, that I get fifth success in 15 trial. So out of 15 trial, if we get 5 successes, automatically it means that in rest 10 of the trial we get a failure only. So here I'm going to type the number of failure as a 10. Number of success is 5. Probability of success is say 0.3. And again, if we want to find out the probability mass function, then I use the command of false. And if I need to calculate cumulative distribution function, then we need to use the command of true. But here I need the probability mass function, so I'm using the command of false. So this is the required probability in this, right? Similarly, if we need, say, number of successes, so for example, if I consider the number of successes as 6, so automatically what is x minus r? Then it will be equal to 15 minus 6. It comes out to be 9. So if I want to calculate the 6 successes in 15th trial, then its probability can be calculated as. So we are going to use the same formula here, but we are going to replace here the number of failures with 9 and the number of successes with 6. Then it will give us the probability as 0.058894. So this is how we can calculate the probability mass function for negative binomial distribution. Okay, now the last one is for the geometric distribution. Geometric distribution. So what about the geometric distribution? Geometric distribution states that the x represent the random variable number of trial required to get the first success. Okay, so for example, if I say that in the experiment we get the first success in 10th trial, so it means that your number of success basically in this case r is equal to 1. The value of r, it is equal to 1. So automatically, how many failures we have in this case? So if we get the first success in 10th trial, so it means that the number of failure will be 10 minus 1, that is 9. Okay, so if we want to calculate the probability mass function, so how do we calculate this? So in this case, we are going to use the command of negative binomial distribution only, because geometric distribution is a special case of negative binomial distribution. But in this case, your number of successes is 1 only. It is fixed, right? So the number of failure for this problem is 9. The number of successes is 1. The probability of success, say it is 0.3. And because I need a probability mass function, so I'm going to use the command of false. So this will be just the required probability. Okay. I hope it is clear to you that how we are going to use the command of Excel to calculate the probability mass function and the cumulative distribution function of the discrete probability distribution. Okay, now let me show you the questionnaire which we have and what we need to do in this particular questionnaire. So in this questionnaire, the sample, that means the data which we are going to use here, it is in the form of a pie chart. This data I have collected from you student only in the form of a questionnaire. So where I have asked you the different questions. So here I have selected this particular question. Yes, this particular your emotional state. This particular part that I have selected for this particular activity. Okay, so here, so I have allocated the different emotional state to the students. So for example, if any student got the emotional state as a joy, so emotional state joy means it covers 55.9% of the respondent. They have selected this particular option. So if any one of the student got this particular emotional state, it means that this is the probability of success because this is the proportion of the student who have this kind of emotional state. So because this is the emotional state allocated to you. So this is your probability of success and rest is the probability of failure. Okay. So for example, if some other student is allocated with the emotional state as a surprise, so for him, the probability of success is 8.9%. So according to this particular probability of success only, you need to solve the problems. So there are different problems. For example, the first problem is based on the probability that out of the 25 selected person, at most 15 possesses the emotional state. So you need to apply the uh, discrete probability distribution to answer this particular question. And apart from the answer of all this question, the student has to upload the PMF and CDF table of Excel. So like I have already demonstrated you that how can we plot the PDF and CDF of the distribution with the help of the command of insert plot. Okay, so here we have plotted the column 2D plot. So I have selected this option 2D column and then we go for more column chart option and there we have this particular option where we can plot this particular graph. Okay, okay, so I hope this video is helpful to you so that you can complete this particular activity. If you're still having any doubt or any query, then you can post your query. I'll try to provide you the solution of the same. Okay. So thank you. Have a nice